So this slide is very simple. We essentially just note down the relative cup products. So we obviously start with what we have already computed. We start with the cochain maps, and we just rewrite what we were writing for computational purposes. So phi acting on the singular simplex from 0 to vk, and psi, second one we are calling as psi, acting from vk to vk plus l. So these induce cup products of the following form. So these are all relative cup products, and details of which you can find on page 209. Essentially all of them are induced from cochain maps. So the first one is you take the co-homology group of the kth part. In the second part you take the relative cup product. Yeah, you choose a subset A of X. Again the coefficients are in a ring R, and take cup product. You land in HK plus L, but the relative cup product, yeah, X comma A lands in R. Now we reverse what we wrote before. So now we'll take HK, X comma A, and HL as X. Yeah. Again we take the cup product, same way. So everything here is induced from the cochain maps. Now again we take, obviously you would have guessed by now, both of them are relative. HK is relative, HL is also relative. That is the kth co-homology group and the lth co-homology group. Again you take the cup product, you land in HK plus L. And in the last part we take two different subsets of X. One is A and another is B. So HL has the B part. I've written A, I will just correct it. So instead of A I should be writing B here. Yeah, so we get HK plus L, A union B. So this you can find page 209 of Hatcher. Yeah, so as I mentioned before, it follows from the cochain complexes. Yeah, and basically restriction of cup product. So we want to be able to define cross product or external cup product, and in order to do so we have to first define induced maps and corresponding induced cup products. So what do we mean by it? Yeah, so let us write down the proposition 3.10, page 210 of Hatcher. So you know the map f from x to y will induce a homomorphism f star between the co-homology groups, and you can see the direction of arrow has reversed. X to y has become y to x. So this map should satisfy the following property. So it should respect the cup product. So this is a homomorphism and this should behave like a homomorphism. Yeah, so the cup product in the ring or the group HN Y should be respected in the cohomology ring or group HNX. So proof. So obviously our strategy is to follow our nose, and we have to define some map like f hash. Now f hash is nothing but a co-chain map, and so this map you can see, instead of f star write f hash, and instead of hn write c. So yeah, just rewrite the map f star and you have a map cny to cnx, and that is f hash map. So what are we trying to show? We are trying to show this equality. Yeah, so this looks precisely like the above equality with hash replaced by star. So you know the hash is a co-chain map and f star is a homomorphism between co-homology groups. So f hash is cny to cnx and f star is hny to hnx. So let us just rewrite what it essentially means. Yeah, so you have to apply this to a singular co-chain sigma of dimension k plus l, and we will then apply the definition of the cup product, split this down, yeah, so I'm just copying the definition of the cup product. Okay, now the definition of f hash is a co-chain map, so it splits with phi f, or reverses, not splits, reverses with phi f. Yeah, by definition of f hash, similarly here with psi f. Yeah, so that is a definition of phi hash of f hash of phi. And this is nothing but the required cup product. Yeah, you know the definition of f hash applied to a map. Yes, end of story. So now we will use the previous slide to define cross product or external cup product. So before we can do so, we have to define a map. So in the previous slide we had defined a map F. Here we define two maps. These two maps are projection maps, and we will write down as P1 times P2. So the first one is P1 goes to X, and the second one is P2 projected to Y. So now reverse the arrows to get homomorphism between co-homology groups. So we have map P1 star precisely in the same manner by which we obtained map F star in the previous slide. So element A gets mapped to P1 star A. Similarly, we have P2 star, reverse arrows on the left. So now we are going from Y to X cross Y. So again, element P gets mapped to P2 star B. So this induces the following cup product, which is called the external cup product. Here the definition is natural. You take A and B and take them to the cup product. And similarly for the relative case. Now the relative case, both the relative cases, they follow from the reasoning given on page 209. Yeah, so HK, HL to HK plus L, precisely as we have written above, but with relative maps. So here in the second part we have the union. So you see A times Y and then X times B. So yeah, so you see A is here and then X is here.